So we've talked about measures of center. We talked about measures of dispersion. The next thing that we are going to look at is measures of position and outliers. So several different things that we're going to look at in this section. The first is probably the most important. We know how to find mean, median, and mode to look at the center. And we've talked about how you can compare two sets of data by looking at the means and also by standard deviation, right? And in general, do we want a bigger or smaller standard deviation? Smaller means more consistent, so most of the time that's better. But it would be useful to be able to compare two different sets of data. So for instance, let's say you had two tests today. You took a calculus test and you got an 89%. And then you took a bio test and got a 92%. Okay, if I just said which test did you do better on, you would probably say bio because it has a higher percentage, right? But there's other factors to consider. What if the average on the calc test was an 85 and you got an 89, but the average on the bio test was a 99 and you got a 92? Then which one did you do better on if you think about it that way? Calc sounds better because you got higher than the average, whereas in bio you got lower than the average. So just looking at one thing, the mean, median, mode, or standard deviation, doesn't always give the whole picture. But we need to be able to take those two sets of data and compare them because they're totally different classes, totally different means. So how can I compare the two values? And that's when we use what's called a z-score. So a z-score tells you how far something is from the mean in terms of standard deviations. So z-score is distance from the mean in terms of standard deviations. And so the mean height of males 20 years or older is 69.1 inches with a standard deviation of 2.8. The mean height of females 20 years older is 63.7 with a standard deviation of 2.7. Which of these people is relatively taller? So that doesn't mean which one's taller overall. It means who's taller with respect to their group. Who's taller compared to other people that are like them. So with these, a lot of times we're going to have a lot of information in here because I have the mean and standard deviation for both groups. So I recommend kind of organizing yourself. So we have men and women that we're going to look at. Okay, so for men, what was the mean? And the standard deviation? Okay. For the women, the mean was 63.7, standard deviation 2.7. So what we're going to do is find the z for each of those. So my x is my particular value. So for the man, we had a height of 83. So z, formula is x, your value, minus the mean, divided by standard deviation. 4.96. So what that means is he is 4.96 standard deviations above average. Okay, think about, like yesterday we used these bell curves, right? And we measured standard deviations. Would 4.9, so almost 5 standard deviations above the mean, be a lot? Yeah. This little graph, we said 99.7% is within 3 standard deviations. So to be 5 standard deviations above average is huge. So he is very tall for his group. Now let's look at her. So we need her value. She had a height of 76. So her z-score, her value minus the mean of her group divided by the standard deviation of her group. Make sure if you're putting these in the calculator, do the 76 minus 63.7 in parentheses. I got 4.56. So it's still very tall for her respective group. She's 4.5 standard deviations, which again puts them way off in the tail here. So very, very unusual. Which one is taller for their respective group? This one is taller because his height was farther away from the mean. More standard deviations from the mean. Do you guys understand what I mean by z-scores? Second thing we want to talk about is percentiles. You guys have seen percentiles before. Probably every standardized test you've ever taken, when you get your scores back, it'll say you scored in the 74th percentile. What does that mean? Does it mean you got a 74% on the test? No. It's telling you 74% of the people that took it got a score less than or equal to yours. Okay, so 26% did better, 74% were either the same or worse than you. So for percentiles, we will use P for percentile and then a subscript, and that's the value such that K% of the observations are less than or equal to it. Okay, so if I gave a test and I said, all right, the 25th percentile was an 80%. What does that mean? 25% of people had a score less than or equal to 80. So 75% got above an 80 there. I'll give you a second if you want to jot down anything there. The next example, I just want to explain what a percentile is. So we're going to basically interpret one of them. So the GRE is a test required for admission to many grad schools. The University of Pittsburgh Graduate School of Public Health requires a GRE score no less than the 70th percentile for admission. Interpret this. Okay, so their score has to be no less than 70th percentile. What does that mean? Yeah. So you have to get a 70th percentile or higher to get in. Okay, here's the 70. All of these people don't. These people do. So it means that the score be in the top 30% for admission. Or you could say it as, you know, it has to be high enough so that at least 70% of the scores are below yours. In different ways, but on these tests, quizzes, homework, it will ask you to interpret them. So that making sure that you understand with the percentile, we're talking about the scores lower. So if you have to be above the 70th, 70% have to be below, you have to be in the top 30. Some specific percentiles that we're interested in are the 25th, 50th, 75th. Those are also called quartiles. Okay, so you have maybe heard of quartiles before. They divide it into fourths. So quartile 1 is the same as the 25th percentile. Quartile 2 is the same as the 50th percentile. Quartile 3 is the 75th percentile. We don't really look at the fourth quartile because that just means that everything is below that value. So we wouldn't really use it. Your formula sheet that we've been using, so it has the z-scores on there. It doesn't have anything about percentile, but you'll notice the next few formulas all have Q1, Q3. Those Q's are representing quartiles. So before we talk about like the next few things on the formula sheet, let's just practice finding some quartiles. So I'm going to give us a set of data. All right, so we have a group of Brigham Young University, Idaho students collected data on the speed of vehicles traveling through a construction zone on a state highway, where the posted speed was 25 miles per hour. Here are your 14 speeds, and I think I even put them in order for you. So I was being nice. Because just like if you're finding, well, let me ask a question. What's another name for the 50th percentile or the second quartile? It's the median. We've already found that, the middle. So when we're finding these quartiles, just like with the median, the data has to be in order from small to large. So I want to find the quartiles. So quartile 1, that's the same as saying the 25th percentile. Quartile 2, that's the same as the 50th percentile or the median. And don't we already know how to find that? All right, let's look at that. So if we have 14, the median would have to be right here. So what would I need to do to find it? Mm-hmm. So we get what? All right. And then the other quartiles, it's basically finding the median again. Quartile 1 is find the median of the smaller set, of the lower set. So here's this half. If I want the middle of that, it would be 28. Quartile 3, or the 75th percentile, that's just the median of the upper half, which would be 38. okay with that? So to interpret this, 28, that's the first quartile. So this means 25% of the speeds were less than or equal to 28. I'm not going to write the sentence for all of them, but how would I interpret the second quartile? 50% speeds were less than or equal to 32.5. This one would be 75% speeds were less than or equal to 38. So make sure you could write those sentences to explain it. I'm going to try to get through at least the next little bit before play people leave. So something that can be useful for us is what's the interquartile range, or IQR. And we know a range is just when you take the highest minus the lowest. So the interquartile range is you take the highest quartile minus the lowest quartile. So IQR is quartile 3 minus quartile 1. That is on your formula sheet. So that is given to you. So if I wanted to find the interquartile range of my previous example, what would it be? So if I look at this one, IQR be 38 minus 28, which is 10. The interpretation of that, so the distance between the first, I think this is the 25th percentile and this is the 75th, right? So how much data lies in the middle? 50%. So if I'm looking at this, it tells us that the middle 50% of data is within 10 miles per hour. There are 10 miles per hour range that had half of our data in it. You can also kind of use the quartiles to tell if your data is skewed. How far is it from quartile 1 to quartile 2? How far is it from quartile 2 to quartile 3? 5. If there's a really big difference in those, that's usually an indication that your data is skewed. So if one of them had a range of 4 and the other one was 9, that would probably tell me that the data was skewed. These are fairly close to one another, so it's probably not too bad. All right. I'm going to pause for just a second because I know. Okay, so let's say that a 15th car goes through the construction zone at a speed of 100 miles per hour. How does that compare to the rest of the data? Is that going to be an...
Skews it.
Yeah, that's going to skew it, isn't it? Because our highest one before was 40. So if I throw in a 100, I want to see how this changes the mean, median, standard deviation, and quartile range, interquartile range. So we're going to do the mean, median, standard deviation, interquartile range. All right, so we're going to do the original and new. All right, we did the median for the original already. That was 32.5. And we had the interquartile range for the original data was 10. Let's use our calculator to get the mean and standard deviation for this. So we need to put those 14 values in our calculator. Bye, guys. Can't wait to see it tomorrow.
Yeah.
All right. We're going to put these values. You're welcome. Sorry I didn't get all the way through it.
No, you're right. That's my fault.
So are you guys entering this into your L1?
And we don't put the 100 yet.
I don't like my notes being so. I'm watching the news. And I have no idea.
So then if we go to one variable statistics.
Did you add these yet?
Not yet. I'm going to do the original data first.
Do you just
So-
want them or one this one?
Yeah, so my mean, let's do 2 here, was 34 or 32.14. Standard deviation was 6.175. Okay, so let's make a prediction. We know mean and median are ways of measuring center. If I throw in a really big value, which of these is going to change a lot?
Both.
Both of them will probably change.
The
Which
mean will change that.
the mean will change more. Okay, what do we think about these?
Standard deviation will increase and IQR will increase as well.
Okay, let's go see. So go to your stat edit. On your L1, just go down to the bottom. And on the 15th value, enter a 100. And then we can calculate one variable statistics. So the mean is 36.67. The median, remember if you go down, it has MED for median is 33. What do you notice right above that? Q1. It tells us that the Q1 is 28, and right below the median it has Q2 or Q3 is 39. Can you find the interquartile range then?
Yep.
39 minus 28 is 11. And standard deviation, we're looking for the S, so 18.504. Okay, so what we're seeing is two of these changed a lot. My mean had a pretty big jump. Standard deviation had a massive jump. So these were a big change. Remember, we've used the term resistant before. Those are the ones that are not resistant. An extreme value really, really changes them. But if I look at these, 33, that went up by a half. Interquartile range went up by 1. Those are small changes. Those values are more resistant. So that, again, goes to show us if we have nice, symmetric, bell-shaped data, we like the mean and standard deviation. But if our data is skewed, then the median and interquartile range are going to be better to look at. Any questions there? The last piece that I want to talk about is how to find outliers. Outliers are really extreme values, so we could all agree that 100 is an outlier, right? We would agree with that. But what if I said 55? The highest was 40. Is 55 high enough to be an outlier? Maybe. We don't really have a clear-cut idea, though, do we? So we need a format for finding that. So for the outliers, outliers are any values lower than what's called the lower fence, or higher than what's called the upper fence. So we actually have a mathematical way of calculating what would be extreme or not. So lower fence, it's quartile 1 minus 1.5 times the interquartile range. Upper fence is quartile 3 plus 1.5 times the interquartile range. And so these fences basically tell you the normal values should fall between them. Anything higher than the upper or lower than the lower will get thrown out as an outlier. And these are on the formula sheet. So you're not memorizing any formulas. We're just using them. So for our final example, let's just check our data for outliers. Okay, so let's use the set with the 100 miles per hour. Okay, so in that, the lower fence, quartile 1. What was quartile 1 of that last set of data that we looked at? Quartile 1 for that set was 28. Minus 1.5, what did we get for the interquartile range there?
11.
All right. So we get 11.5. Do we have any values smaller, any speeds lower than 11.5? So no outliers so far. Upper fence, quartile 3. What did we find for quartile 3? Plus 1.5 times the interquartile range. Get 55.5. So would 50 have been an outlier?
Yeah.
50?
Or no?
No, but is 100?
Yeah.
Yes. So the 100 mile per hour is an outlier. So this is where we've gone through the whole section. I will likely do a few more examples tomorrow. We didn't have very many today, so I'm probably going to do a few at the beginning of class tomorrow. But I'll go ahead and give you the, well, I did give you the